In this video, we will cover the basic chunking strategies that we mostly use in our company agency, and we will follow up on the previous video regarding how to structure your knowledge base. But in this video, we will basically delve more deep into each individual strategy. What are its benefits, pros, cons, when to use it, how to use it, and so on. So let's quickly summarize from the previous chapter what is chunking. When you build a search system that uses AI to answer questions from documents, you need to break those documents into smaller pieces called chunks. We know that already, before uploading them into a vector store or knowledge base. The AI then searches through these chunks to find relevant information. Why chunking matters? It's how you split your documents that dramatically affects how well your system finds the right answers. LLMs have limited context windows. We already know that we cannot fit huge PDFs, documents, or entire websites with dozens of thousands of URLs into a single LLM call. So that's why we need to chunk that content and retrieve it properly. And retrieval itself can find or return only most relevant pieces of documents, and it gives LLM focused information without overwhelming it with irrelevant context. So let's take this example text. As you can see in here, I have this example Markdown text. It's structured like this. It's about a Kepler space telescope. So this is only a dummy text for the example. And I will show you basically each and every strategy, how it would basically deal with this kind of content and how it would basically chunk it into the individual chunk and how it would perform. So let's look at the first chunking strategy, which is called fixed size splitting, or in technical name recursive character splitter or fixed token cut. It cuts the text every n words or characters or tokens, no matter what. So if we were to take the previous example, the text, and we were to choose the boundary, for example, 50 tokens, so it would split the text no matter what, regardless its logical meaning. And it would split it first 50 tokens, second 50 tokens, third 50 tokens, and so on. So as you can see, it would take the text and just split it here, somewhere in the middle of a sentence. Then the second chunk immediately after that would continue. Then it would be split again in the middle of the sentence. Then the third chunk would continue, and so on. So basically the biggest problems are it cuts mid-sentence, it starts and ends mid-sentence, and it mixes unrelated sections together, which, as you can guess, it's not really good for later retrieval quality or vector search. It's best for when speed matters more than the quality or when you have a tight budget. Also, it's important to mention that most of the bot building platforms, no-code platforms like BotPress, VoiceFlow, N8N, Make.com, they innately use this exact chunking strategy, and they do not give you pretty much detailed control how you want to tinker the strategy. They at max give you how you can tinker with the max token count, basically how large is the max chunk size, and that's all, but they don't enable you to use these following chunking strategies that I will show you immediately. Let's look at the second strategy, header-based splitting, or in technical name Markdown header chunking. So how it works, it basically looks for headings. For example, these hashtags, when you convert the HTML content into a Markdown content, it converts the titles or chapters or headlines into these characters. One hashtag, two hashtags, it's like headline level 1, headline level 2, and so on. So it keeps everything under each heading together. So if we were to take the example text from before, as I showed you, we would split it in 4 different chunks, where under each header would basically belong together the information that fits under it, right? So we would have 4 chunks, exactly how it would be ideal to split it in this example text. So you would have this first chunk, this second chunk, this third chunk, and this fourth chunk, whereas the text that belongs under it is actually under it and it fits into a single individual chunk, right? So it's perfect that each section stays intact, but its limitation is it doesn't work if your document has no headers, that's first, and also if the text under that section is larger than the max token count allowed for the vector store, you have a problem, and basically you need to split it again, and then you don't have the header again for it, and basically you are losing the meaning of the chunk, and the purpose of this strategy, right? So it has pros, but it has also cons. Mostly this strategy is very good for structured documents or URLs. Now we are getting more in the advanced territory where we use vector embeddings to basically assess the meaning and split the chunks by logical meanings or topics changes, right? So the technical name of the strategy is semantic chunking. How it works, AI measures how similar each sentence is to the next. When the topic changes significantly, for example, how it works to what they discovered, it creates a new chunk. So example output, again for the same text, we would have these chunks by using this strategy. First chunk would be like this: the Kepler Space Telescope as a space observatory. It looks for periodic dimming known as transits. Why group together these words? Because AI sees telescope, instrument, and monitor as related concepts, and it can shuffle these and group them together by meaning, right? So for example, the second chunk would be during its 9-year mission, Kepler observed over 500,000 stars and conferred over 2,000 planets. Numbers and discoveries, again, new, separate, different topic. The mission ended in 2018 when spacecraft ran out of fuel and deactivated termination topic, right? So the biggest benefits of the strategy is it groups ideas together, even if the document has no headers and no structure, but it can basically, it's a little bit tricky to set it up and tune it because you need to tinker quite a lot with the semantics and basically the settings of the strategy, and it can reshuffle the text a little bit. And I'm not used to use this strategy quite a lot, but it's getting into the territory when you are starting to use for this vector embeddings. But these next strategies I will show you use LLM, and I like those strategies more in my specific use cases. But this is, as I said, one of the strategies when you can start to use basically LLMs to measure how similar each sentence is and how the topics change. So when you are more advanced, you can utilize this strategy quite well, but I wouldn't recommend this for beginners. Now, following strategies are my favorite. The first strategy, AI decided splitting, or in technical name, LLM-based chunking or agentic chunking. So how it works, the AI reads the entire input text and decides the best places to split it based on logic and flow. So what's important? Why not to ask AI to output the full text with split markers when you start to implement this strategy? What first comes in mind is basically to take the entire input text, throw it into the LLM, and let it output the entire text again and basically show you where the splits are. But this is not the correct approach how to implement this strategy, because it's quite costly and it can cause duplicates all input tokens as output. And as you know from the nature of LLM, it can hallucinate, and when you have really sensitive content, you don't want the LLM to basically output the same exact content as you input it into it in the first place, because it can shuffle some characters or change some meaning, hallucinate or something. So also it's very slow, massive output generation. If you were to take entire document and put it into the LLM, you would need to output the full entire document without any single character changed, right? So there is quite a huge hallucination risk. AI may alter the original text, and the output token window limitations are very bad in this use case, right? Because if you were to take the entire document and you would like to output it as well without any changes, you would be limited by the output token context window, right? The basically biggest models nowadays have over 60,000 tokens limit, output token context window, and huge PDFs and documents can have even hundreds of thousands or even millions of tokens, right? So what's the correct process, basically how to utilize this strategy, because it's very good and it's very, very precise. I would say most precise from all chunking strategies that we will cover, but you need to basically take the correct approach how to implement this strategy, right? So phase one, you need to pre-split the content with index tags. No AI needed. Split text into small fixed size pieces, for example 50 tokens, 100 tokens, and add these numbered tags, right? So if we were to take the original text in the example, we would basically use these fixed tags after, for example, 50 tokens, and not chunk the text, but pre-chunk it by including these tags into the original text, right? So chunk 0 up to here, chunk 0, another 50 tokens, chunk 1 up to chunk 1 here, and we just take first 50 tokens, then the second 50 tokens, third 50 tokens, and so on. But we are not utilizing AI yet in this moment. We are just inputting these tags into the input content. Then after that is phase 2, where you use the AI with minimal output, just numbers. Basically, you take this entire input text with these tags included after 50 tokens in this example. You all throw it into the AI, into the LLM, and you let it output only basically the numbers. Where would it be ideal to split it after the tags with each indexes, right? So, for example, we would use very intelligent LLM or AI, for example. Nowadays it would be Claude 4.5 Sonnet, for example, and we will throw this entire text into it, and it will tell us that we need to split it after the chunk 0. As you can see over here, after the chunk index number 3, which is here, after the chunk index number 5, and after the chunk index number 7. So what it means? It means, right, that the first chunk would be here, and the AI basically assessed, generated us that it would be best based on the logical meaning of the text, which doesn't have to necessarily have any structure headers. We are using the LLM intelligence to intelligently assess where the logical splits should be, as when you were to look at this text and you would know that this information basically fits together, right? Then we would split it after the index 3, so it means that chunk 1, 2, and 3 should be in singular next chunk, right? It was named after astronomer Johannes Kepler up to here of there on a star. So this would be the second chunk. Then we would split it after the index 5. That means that the third chunk would be these two, chunk 4 and 5. Then we would split it after 7. So it means that the fourth chunk would be this information together. So we are not overloading the output token context window of the LLM. We are only using LLM to intelligently assess where to split the pre-splitted input text, basically. So the AI output only 10 tokens, for example, not the entire document. And the last phase, the phase 3, is programmatically merge it without any AI needed, right, into the resulting chunks and output it into the vector store. So as I said, based on the split after 0, 3, 5, 7 indexes, merge the chunks as I showed you. This would be the 0 chunk, chunk 1, which is this information, the Kepler up to other stars, the Kepler up to other stars, right? So this is the chunk number 1, then 1 up to 3, 4 up to 5, and 6 up to 7. So these are the 4 chunks. And we utilized AI with its intelligence to assess where to split the content, and no matter, regardless the structure or nature of the content, be the document, URL, or any other kind of input content, you utilize any intelligent model basically to assess the optimal boundaries, right? So it's best because AI decided semantically the optimal split points, and it preserved the original text exactly. It has also low token cost, and it's best for, as I said, messy documents, or for example even transcripts or text without any clear structure. Another pro tip: combining the previous strategy with summarization. When AI decides that chunking may create chunks that exceeds your vector store's maximum chunk size, which can happen in lots of times, you can combine it with a summarization strategy that we will cover now. But AI decides the optimal semantic boundaries. We already know that it creates the logical chunks, right? If chunk is too large, you can apply the summarization of that particular chunk to condense it, and for it to comply with the vector store max chunk size, right? So it results in semantically coherent chunks that fit within the vector store size limits or limitations, right? This hybrid approach gives you the best of both strategies with intelligent LLM-based splitting and guaranteed size compliance. So let's look into this summarization strategy, and it can a little bit bleed into a structured output as well. The technical name of the strategy is structured output or Q&A format, or you can read in multiple studies, it's called propositional indexing. How it works: instead of keeping the original text, you extract only the pure facts as Q&A pairs or other structured formats like JSON or any other key value pairs, right? So example output, what would happen if we were to use summarization on this example text? We could convert it into Q&A pairs like this. So instead of the original full text, we would summarize it into following pairs of question and answer. So what was the Kepler Space Telescope? It was a NASA observatory designed to discover Earth-sized planets, right? What instrument did the Kepler use? A photometer that monitors star brightness. So as you can see, we are basically reducing the text, the input full text, to comply with the token limits of arbitrary choice, and we basically extract the pure factoids or facts or factual Q&A pairs, you could say, from the original text, right? So this is best for FAQ systems, databases, when users ask specific questions. Also, you can have different variants of each question, right, and the same answer for it. So you can basically have comprehensive questions for each fact, which enables you to more reliably retrieve the data, the specific fact from the vector store. I would say its only downside is that it can lose the story and context between the facts. So when you are using, anytime you are using LLM or AI, right, you are basically relying on the prompt you gave it and how it processes the input text, and you need to prompt it a little bit more carefully for not to lose the important facts in the process, but it very reliably condenses and summarizes the text, and that's one of the biggest use cases of LLMs, right, in the first place. So summarization strategy, when you want to have a structured output, very structured knowledge base with pure, for example, tables like Q&A pairs, or for example, when you have an e-commerce site, you would have product tables, right, where there will be product name, product description, product price. So that's another example of structured output. Now let's look at some enhancement strategies that you can add to any chunking method we have already covered. These enhancements can be combined with any chunking strategy to boost the search and retrieval quality. So one of the first enhancements would be adding document summary. Basically, when you create summary about the entire URL or document you are scraping, and you prepend it before each and every chunk, in the later LLM generation phase, the LLM can more correctly and with better precision basically reconstruct the entire original content and have a big picture about the particular chunks, how they basically fit into the overall picture, and you get higher, not only retrieval precision, but higher LLM generation precision. So what it does, adding document summary, prepends document title, topic, and context to each chunk so it stands alone. For this example of, for example, text, you can see that source document summary would look something like this. Source, NASA Kepler Telescope report 2009 up to 2018, exoplanet detection. So it would be basically high level summary about the entire document, and we would of course use AI for that, and we would prepend that document summary before each and every chunk, so that there would be enough context for the LLM to guess how the specific chunk fits into the bigger picture of the entire page. You can do also, you can add search keywords, basically the most pertinent keywords optimized for vector search. You could create those via AI as well and prepend those like search queries before each and every chunk. So that's also computational token-wise a little bit more expensive because you would do that via AI step for each and every chunk, but also it boosts the retrieval quality much more. or it basically heightens your chance to get the correct chunks back from the vector store, because most of the time how user will search for that specific chunk will be some kind of variation of that specific search keyword, right? And you can also do both at the same time, and that way your rec accuracy and vector search retrieval will be at the highest possible level, right? So why to use enhancements? The problem, for example, when you would have standalone chunk cut in somewhere in the middle, and it wouldn't have context of the entire page, right? So for example, there would be chunk saying the mission ended in 2018. It's useless because the AI doesn't know which mission, right? So before the ambiguous chunk, the mission ended in 2018 when spacecraft ran out of fuel, you would have the prepared source page summary prepared before that chunk, and now it's certain, right, what we are talking about. And if we are certain what it's about, LLM will be as well, right? So you can see here the source page document summary prepared before that specific chunk of information. So now any search for keywords like fuel or Kepler returned a chunk that makes sense on its own and also has higher rec accuracy and a bigger chance to retrieve the chunk from the vector store. So now let's compare each and every strategy, how they basically differentiate in terms of pros, cons, cost, and retrieval and LLM generation accuracy, and we will summarize everything up in this neat table. So first we have the fixed size strategy, as we called it, recursive character splitter. It cuts text every X tokens, it's fast, simple, predictable, but it often cuts middle of the sentence, and it loses the important context. It doesn't have the context of the entire page, right? So it's low in terms of cost and also low in terms of retrieval and LLM generation quality. Then you have header splitting, Markdown header chunking, right? When you split the document by headings, and it keeps topics and sections together naturally, but it only works if the document URL is properly structured and has these headers. The big con of this strategy is length of the information under each header must comply with the vector store's max chunk size limit, right? So the cost is also low. The retrieval quality and LLM generation accuracy is a little bit better in this case, because you have the overall chunks that belong together in the separate chunks of information, right? Then we are getting into territory when we are starting to use vector embeddings, so we can use semantic chunking and chunk the content by its meaning. The AI detects when the topic changes and splits there. It groups the content and chunks smart by ideas shifts or topic shifts. It's a little bit slower, needs a lot of tuning to work well, and length of the semantic group must also comply with the vector store max chunk size. Cost is a little bit bigger because we are starting to use vector embeddings, but the retrieval quality and LLM generation accuracy is quite high. So the last two are my favorite, as we've already covered. I decided LLM-based or Agentic Chunking. AI reads the entire text and decides where logical breaks are, so it handles messy, unstructured text, even structured, unstructured, any kind of text very well, because you are using the overall LLM intelligence to basically intelligently assess where the optimal splits should be, right? So it requires AI processing, that's why it's a little bit more costly, because you are throwing the entire input content into the LLM. And also the length of the information in each calculated chunk must comply with the vector store max chunk size, right? And by using this strategy, I have to say the retrieval quality and LLM generation accuracy is very, very high. And last is summarization, when you are utilizing AI to create basically structured output. For example, the Q&A format, question-answer structure, we've already covered. It converts the text into question-answer pairs or any kind of structured data or table. Very useful when you want to have structured knowledge base, for example, for e-commerce sites or Q&A, FAQ-based type of databases. It's perfect for clear and concise types of answers / data. Option to influence summary length perfectly complies with the vector store max chunk size limits, because you can, as I said, perfectly set it to the exactly desired chunk size, right? When you are using the LLM and utilizing the prompt to influence it. And the only downside of this actually is it's the most expensive of from the strategies we've covered, right? Because you are basically outputting the entire new chunks from scratch, and it can lose a little bit here and there some context or story, or it can also hallucinate, right? Because we are outputting output from LLM, and it's not ideal for long lists of information, right? So the more comprehensive the information is, and you need to maintain as much content as possible in the resulting, for example, answer field, the less optimal is this strategy. So that's the basic comparison of these strategies. And for one last time, we can look at the key highlights and key takeaways from this session. So no single strategy is best. You must choose based on your document type, URL, and of course your budget, right? The more AI steps you utilize, the more expensive chunking strategies you use, the more expensive is gonna be your processing. Strategies can be combined together. Most production systems use 2 or 3 strategies together combined with other type of enhancements on top of it. So start simple and improve later. Begin with, for example, Markdown, header-based chunking or fixed-size chunking, and then upgrade and compare those strategies, how they basically execute and perform for your specific use case, right? Test with real questions. The best strategy depends on how your users actually search. So multiple people search in multiple different ways, right? So that's the phase of testing. And context matters. Adding source summaries, keywords to chunks often gives the biggest quality boost.